A warm welcome to everyone listening to this video. Welcome back to the channel. In today's session, we are going to explore one of the most widely used ground improvement techniques in geotechnical engineering, that is a dynamic compaction method. So, this technique plays a crucial role in improving soil strength, reducing settlement, and preparing unstable land for safe construction. This topic is a part of Unit 5 Ground Improvement Techniques from the course Foundation Engineering, conducted by Department of Civil Engineering, SNS College of Technology. Let's dive into how heavy weights dropped from significant heights can transform weak soil into a strong foundation. So let's have a gist about dynamic compaction. Dynamic compaction refers to the process of dropping heavy steel weights known as dampers from a considerable height directly onto the ground surface. These tamper weights typically range between 6 to 20 tons and they can be dropped from heights of 40 to 80 feet using large crawler cranes. The fundamental principle is simple but powerful. The high energy impact produces shock waves that travel deep into the soil, rearranging the soil particles into a denser state. This method is especially effective for the densification of soil, unlike surface rollers or vibrating compactors. This dynamic compaction influences soil layers up to 12 meters deep, making it ideal for large scale land development projects. So, we can picturize the machine with damper and hammer drop illustration. Here you can see the machinery used for dynamic compaction. A crawler crane suspends the heavy steel damper, lifts it vertically, and repeatedly drops it onto designated grid points across the site. Each drop delivers massive energy into the ground, sometimes equivalent to several megajoules of force. So this is the principle behind dynamic compaction method. The primary purpose of dynamic compaction is to transmit high energy waves deep into compressible and loose soil layers. Unlike shallow compaction methods, it affects only the top few meters, whereas dynamic compaction can improve soils at greater depths. Advantages of dynamic compaction are it is one of the major reasons as it is having a strong list of advantages. Let's look into the most significant one. First one is deep densification. It can effectively densify soil up to 12-meter height and it is a cost effective solution compared to deep foundations. It accelerates construction schedules. Once the compaction process is complete, the site is ready for quick construction. And also it reduces the risk of liquefaction and improves the bearing capacity of soil. And the major disadvantage of dynamic compaction is it is not suitable close to the buildings due to high vibrations. In this method it cannot be used within 30 meters of existing buildings. So it must be kept at least 15 meters away from underground pipelines and services. If the water table is too shallow, if it is less than 1.5 meters from the surface, the technique becomes ineffective. And also, if the soil has more than 20% of fine particles, it is significantly less effective. These limitations guide engineers deciding when and where to apply this technique. And the applications are dynamic compaction is widely used in many large scale ground improvement projects such as densification of weak soils, loose sands, collapsible soils, mine spoil, or rubbish fills. And also in land reclamation projects where ground is made from hydraulic fill or dredged material. And also in port and airport platforms, roadway and railway embankments, heavy storage tanks, sanitary landfills, and so on. So, to summarize dynamic compaction, it is a powerful and cost effective technique for improving deep soil layers and preparing the ground for safe construction. With the ability to reach the depths up to 20 meters, it reduces the risks of liquefaction. It plays an essential role in model infrastructure development. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more civil engineering content. Thank you.